earlier lecture, we studied the logical structure of the Oracle databases. A part of the logical structure of Oracle databases, we will be further studying the logical structure in deeply in the upcoming lecture. But for now, I have divided the Oracle physical storage structure into 11 parts. What is inside the Oracle physical storage structure, like data files, online redo log files, control file, etc. And this is the first lecture in that series. We will be studying Oracle physical storage structure in complete detail, starting from the data files. We are going to completely understand one of the most fundamental physical structure in Oracle database, which is the data file. If you are learning Oracle administration, you need to understand data files are extremely. You need to understand data file extremely and deeply, because almost everything related to database storage eventually come back to them. We will not just memorize the definition of a data file. We will understand what a data file actually is, and where it belongs in the Oracle architecture, how Oracle store data inside it, how data files grows, and how they relate to the table spaces. Is in the earlier lecture, the logical structure we studied. What happened when a data file become full? What happened when data file is lost or corrupted? And what a DBA need to monitor and manage in the real life scenario in a production environment. Let's start. The first question is like, what is a data file? In simple word, an Oracle data file is a physical file on storage that Oracle uses to permanently store database data. Think about normal computer, our laptop, our home personal computer, for any computer, which if we create a file, any file in text format, suppose customer.txt, that file exists physically somewhere on our laptop in the storage. Oracle works with physical file in a similar way. When Oracle need persistent storage for database object, the physical storage is provided through their data files. There are three main rules. First is that about data file. First is like every Oracle database must contain at least one data file. The second rule is one Oracle data file correspond to one physical operating system file on disk. As we create a data file inside Oracle database, an associated physical operating system file is also created with a .dbf extension on the storage. And the third rule is that each data file belongs to one and only one table space at a one time. However, the reverse scenario is a little bit different, as a single table space can contain multiple data files. So we can visualize this like we studied earlier. Table space can have one or more data files, like data file 1, data file 2, data file 3. And all the three physical files belong to the same logical table space. This relationship is extremely important. So let's slow down here. A database is the overall Oracle database. A database is the overall Oracle database, and inside the database we have logical structure containers, which we call Oracle table spaces. Table spaces are logical structure, and under those table spaces we have physical structures called data files. So if we create a table space called user, we could have one or more data files with .dbf extension, like user 01.dbf, user 02.dbf, user 03.dbf, and as the size of the database grows, we can add more and more data files to this user table space. But at this stage, we need to make sure that all three files belong to only a user table space. One data file, which is physically created on the disk, cannot be associated with two table spaces, which is a logical structure at the same time. The table space is therefore giving us a logical view, while the data file provides us the physical storage. This distinction is extremely important for an Oracle DBA. A user normally thinks my table is in the user table space. The operating system point of view, the operating system sees that there are several physical files, data files consuming disk space. Oracle sits between these two views and manages the relationship. Let's make the difference very clear. A table space is a logical structure. A data file is a physical structure. Imagine a warehouse company. The company has a warehouse called users. The warehouse may actually consist of three physical buildings: building 1, building 2, building 3, which we, for this example, compared with the data file user01.dbf, user02.dbf, user03.dbf. The company sees one logical warehouse. Physically, there are three buildings. In Oracle, same scenario. Table space is a logical warehouse, and data file are physical buildings. This analogy will help us understand many Oracle storage concepts later. What actually lives inside a data file? Now we need to go one level deeper. What actually exists inside a data file? A data file is not simply a giant text file containing rows. Oracle organizes the space inside the data file into Oracle data blocks, as we already studied in the logical structure. Blocks are the fundamental units through which Oracle manages database storage and IOs. Those blocks are then used by higher level structure. Table use storage, indexes use storage, logs use storage. Other Oracle segments use storage. So conceptually, data file contain blocks. Blocks makes up extents, and extents make up segments. And segment represent objects such as table and indexes. This connect the physical storage lecture with logical storage lecture, which we already studied previously. From the table to this. This is one of the most important diagram in this entire Oracle storage architecture. We started with logical database object, for example, a table. The table has segment. The segment consists of extents. Extents consist of data blocks, and those blocks physically reside inside data files. Finally, the data file exists on the underlying storage. So when someone asks you, the table is consuming like this much 500 gigabytes of space, that doesn't mean there is 500 gigabyte table file. It means Oracle has allocated storage to this table segment through extents and blocks, and those blocks ultimately consume physical space inside one or more data files. Let's take a practical example. Suppose we create a user table space with three data files: user01.dbf, user02.dbf, user02.3.dbf, and each of a size 32 GB. The table now has more than around 96 GB of physical capacity. And the important point is that the application does not normally care which data file contain the individual table blocks. Oracle manage this allocation. The DBA thinks at two level. Logical level, how much space does my user table space have? And at the physical level, where are its files? How large are they? And what storage are they consuming? This distinction becomes extremely useful when troubleshooting space problem inside the Oracle database. Another structure we have is the logical view and the physical view. There are important special files which are uh, big files table space. In normal table space, we can in normal table spaces we can have multiple data file. A big file table space consists of exactly one data file. The advantage is simplifying the management of very large logical storage container. Instead of managing many individual data files, the DBA can manage the table space as a single unit. However, the fact that there is only one data file does not mean the database stop using Oracle blocks, extends, and segment. Those logical storage concepts remain the same. The difference is primarily the relationship between the table space and the physical data file. How is a data file created? When a DBA creates a table space, Oracle needs physical storage. The DBA specify a data file. For example, we give a command that create table space app underscore data a data file and the full path of the data file and size in the start is 10 GB. This tell Oracle to create a data file of 10 gigabyte. The exact syntax and storage architecture can vary depending on whether the database uses a file system or automatic storage management or Oracle managed file or another storage configuration. But conceptually, the operation is always the same. Create a logical table space and provide physical storage through a data file. One of the most important data file property is auto extend. An Oracle data file can automatically expand when it runs out of space if the DBA created it with the option of auto extend parameter. Imagine a data file currently has 100 gigabyte of space. The database consumes most of that space. When Oracle need more physical space, an auto-extendable data file can grow automatically. The DBA can define how much Oracle should add during each extension using the next value. The DBA can also define the maximum size using max size parameter. For example, conceptually, the initial size is 10 GB, auto extend is on and next 1 GB, and it can maximum grow up to 100 GB. This means that the file starts at 10 GB and can grow in an increment of 1 GB until it reaches 100 GB storage space. But there is one extremely important point. Auto extend does not create storage from nowhere. The ultimate limit is the disk volume where the data reside physically. The danger of auto extend. This is an important DBA lesson. Many people hear auto extend and think Oracle will automatically handle the space. This is only partially true. Oracle can automatically increase the data file, but the underlying storage still has its own capacity. Imagine a file system with only 5 gigabytes space free. Your data file wants to grow by 10 gigabytes. Oracle cannot magically create those 10 gigabytes space because at the back end inside the storage we have only 5 gigabyte left. So the storage layer must provide the space. Therefore, blindly enabling unlimited auto extend can be dangerous. A DBA should monitor file system capacity, ASM disk group capacity, data file growth, table space usage, and expected application growth. Auto extend is an automation mechanism, not a capacity planning. In our production database, We have so many databases, and we have created scripts which generate daily reports about each of the table spaces we have inside our production databases, and its usage and growth on a daily basis, and share that growth with us on email. The next question is, should you create one large data file that can keep extending, or we should create several smaller data file with control growth? Multiple data file can sometimes make operational management easier, particularly when moving or managing individual files. However, this is important point for modern Oracle environments. Do not blindly apply historical data file size recommendation from older Oracle release. Modern Oracle database commonly use data files much larger than the size discussed in Oracle previous version. Depending on the Oracle version, file system, automatic storage management, and storage architecture. The important lesson is data file sizing is a design decision involving manageability, storage capability, growth, and operational requirement. Now let's answer a very common question. Where does the data actually go? When a user execute an insert command, does Oracle immediately write the row into the data file? Not necessarily. This is where understanding the Oracle instance become most important. The user sends SQL to the Oracle instance. Oracle processes the request and changes block in the memory, particularly in the database buffer cache. Oracle also generates redo describing the change. The redo is written to the online redo log file as a part of transaction durability. The change database block can remain in memory for some time. Eventually, Oracle database writer process write dirty blocks to the data files. So data file writes and redo writes are two different concepts, which we will study in the instance part of this tutorial series in the coming slides. Now there we have data file and what is redo log file. This distinction is so important that we need to repeat this one once again. A data file stores the database block, and a redo log store information about that change. Suppose a customer changes their account balance. The change block eventually need to exist in the data file. But Oracle also record a redo describing that change. If the server crashes before the change block reach the data file, Oracle can use a redo during instance recovery. So, data file is where the data ultimately lives, and redo how Oracle protect this change. Now let's discuss one more important common DBA problem. Suppose we get a notification that a table space has been full. What does actually that mean? It generally means Oracle cannot find enough usable free space in the table space for the requested allocation. The DBA then needs to determine why. Is the data file too small, or is auto extend disabled? Has the data file reached the maximum size? Is the underlying file system is full? Is the ASM disk group running out of usable space? And depending on the situation, the DBA may add another data file, resize the old or existing file, or modify its auto extend configuration. Notice the distinction. Database space problem and physical storage problem are not always the same thing. A table space can need more space while the underlying file system still has plenty of capacity. Conversely, a data file may be configured to auto extend while the file system is almost full. So you need to inspect different architecture, different scenario in real life production database systems. So this give us three different level of troubleshooting. First, does the table space have free space? Second, can the data file provide additional capacity? And the third is, does the underlying storage have enough storage capacity or free space available? These are different questions. For example, you may have a table space with a data file of 500 GB. The data file itself may be almost full, but the file system may have 300 GB free space. In that case, we may need to extend the data file. But imagine instead of like the that file system has only 2 GB free. Then extending the data by 50 GB is impossible until the underlying storage problem is resolved first. This layered thinking is one of the most important skill in a DBA scenario. Another common question is, can I shrink a data file? The answer requires underlying understanding where the use blocks are located. A data file might be 500 GB in size, but containing only 300 GB of allocated object. That does not automatically mean Oracle can reduce the physical file to exactly 300 GB. The block that remain allocated near the end of the file matters. Oracle has a mechanism for reclaiming space in certain circumstances, but shrinking data file is not simply a matter of deleting unused rows. This is why a DBA should never run a data file shrink operation without understanding the table space, segment layouts, usage, and recovery scenarios. The important model is logical free space inside a data file is not automatically the same thing as file system space that can be returned to the operating system. Now, let's move to a disaster recovery scenario. What happens if a data file is physically lost? Imagine the disk containing an important data file fails. The physical disk fails. The database no longer has access to that physical file. The solution depends on the exact circumstances, database mode, redundancy, backups, and the type of failure. This is where the relationship between data files and redo become extremely important. A data file backup provide an older physical copy. Archive redo can contain the changes generated after that backup. Oracle can restore the data file and apply the required redo to recover it toward the desired point. So, a data file is not just a storage object, it is also a recovery unit that must be protected by appropriate backup strategy designed by the database administrator. As an Oracle DBA, you should be able to inspect and monitor data file at any time. One of the most useful data dictionary view is DBA underscore data underscore file. It allows you to see information such as data file ID, physical file name, the table space, the current size, whether auto extend is enabled or not, and the maximum size of data file. This kind of information we use when investigating table space growth or storage problem. Another useful view is v dollar sign data file. This gives us runtime information about database data file. When troubleshooting a database, don't rely on the operating system. Linux may tell you that the physical file exists, but Oracle also need to know about that file and its database state. Therefore, always think in two directions: operating system view and Oracle database view. Managing a data file is not just creating them. A production DBA needs to monitor the entire life cycle, how large is the file, how quickly it is growing, is auto extend enable or not, what is the maximum size, how much free space is remaining inside the table space or the physical storage, does the file system have enough capacity, enough free storage, if we are using automatic storage management, does the disk group have enough usable space? Are the data file included in the successful backup? And is the underlying storage performing properly? Data file management is there for both a database task and a storage management task. Let's bring everything together in the Oracle database contain logical tablespace. Tablespace are backed by physical data files, and data file contain Oracle database blocks. Those blocks ultimately store the content of database objects. When user modify data, Oracle works with blocks in memory and generate redo. Redo provide the changed history required for transaction durability and instance recovery. Later, database writer process write dirty block to the physical data files. If storage become full, a DBA must manage data file capacity and underlying storage. If a data file is lost, backup and recovery mechanism become important. And if the database uses automatic storage management or other storage technology, the physical placement of those files is managed differently. This is one of the complete mental model of the Oracle data file, which I tried to explain in this lecture. Whenever we are dealing with data file in production, ask yourself question: which table space on this file, where physically it is located, how large it is, how much usable space is remaining, is auto extend enable or not, what is the maximum size of this data file, how quickly is it growing. We need to use some queries to get estimated growth of our database and compare that with our table space as well. Does the underlying storage have enough capacity? Is it protected by a valid backup? A valid backup scenario is defined to take backup of all the data files or not. And finally, can I actually recover this data file if the storage fail? A DBA who can answer these questions understand data by data file operation, not just theoretically. Before we finish, let's summarize the most important point. A data file is a physical Oracle storage structure. Every database required at least one data file. Every data file belongs to exact one table space. A table space can contain multiple data files. A big file table space has one data file. Data files can automatically grow using auto extend parameter. Max size parameter can limit the growth of a data file, but physical storage remain the ultimate limit. Data file contain Oracle blocks that ultimately hold database object data. And data file are fundamental to backup and recovery. If you remember only one sentence from this lecture, remember this. A table space is a logical structure, storage container, and a data file is the physical storage file that provides the space behind that container. In the next lecture, I will try to explain Oracle Online Redo log file, so which is also a physical structure of the Oracle database side. So keep with us up to the next lecture.